Hello guys, so we're going to look at this topic called indices. You can also call it index notation. So now, um, what is the notation of an index? I'll give you an example. For instance, if you have A and B like that, this simply means the one that you have down there is called the base. So A is called the base. Then the one that you have on top, I know you are most familiar with calling it the power, because that can be called A to the power B, but it can also be called an index. So it can also be called an index. Hence the topic indices. Alright. So indices is a topic in math that involves bases and powers. So now we're going to look at certain things in here that will help us to answer all the questions in the final exam that might come on this topic. So we're going to start with the first thing, and firstly we're going to look at the laws of indices. Okay, so indices has some laws that you have to follow in order for you to fully understand how you about to go about questions. So on the laws of indices, we have the first one, which is if you have a base, so you have indices of the same base. So let's say this is a to the power m multiplied by a to the power n. So the bases are the same. So what do? The powers should add. So if you have indices of the same base, so what you do is that, so this is base A, this is base A, the powers should add if there is multiplication here. So the powers can only add if there is multiplication there. Alright, here is an example. If we have 3 to the power 2 multiplied by 3 to the power 4. So since the base is the same, this is 3. So what you do is you maintain the base, then you add the powers. So what is 3 plus 4? So this becomes 3 to the power 3 plus 4 is 6. So that becomes 3 to the power 6. Okay. The other part is when you have indices of the same base and we are now using division here, you subtract the powers. Look at an example. If we have m to the power 7 divided by m to the power 3, you maintain the m, then you subtract the powers. So 7 minus 3, that gives us 4. So we get m to the power 4. Right. Look at part C. If you have the power of a power, if you have a base raised to a power, and that power has also been raised to a certain power. So in short, we are saying a power of a power. So if you have two powers, so what you actually do is you multiply the powers. So we have a to the power m, then everything to the power n. So what do we do now? So what we do is you maintain the base, then you multiply the powers. Look at here. We have m to the power 3, then raised to the power 2 again. So what you do is you maintain the m, then you multiply the powers. So this becomes m, 3 times 2, 6. So that becomes m to the power 6. That's how you can simplify that. The other law is when you have any number or letter that is raised to the power 0, the result will always be 1. Apart from that base should never be 0. Okay, so that base should never be 0. Look at an example. 2 to the power 0 will just get a 1 here. Part E, m to the power x over y. So this is the part of indices we call fractional indices. So if you have a base raised to a fractional power, what do? The first thing that you do, you introduce the square root, then let the base be inside the square root. So the base inside the square root, then the fraction has got the top part and the down part. It has the numerator and the denominator. So what do we do? So the one which is down, which is the denominator, is the one that comes here. So it's the one that comes here. Then the numerator becomes the power of the whole thing. So that is how you can do that. Look at an example. 4 to the power half, 4 to the power 1 over 2. So I said firstly introduce the root, then let the base be inside the root. Then the denominator becomes there, then the numerator becomes the power of the whole thing. Then what do we do now? So there's a 2 here. So we're asking ourselves to say, is there any number that we can multiply by itself twice so that we can get 4? What number is that? So that number is 2. If we say 2 times 2, look at here. If I say 2 multiplied by 2, I'm going to get 4. So meaning we're just interested in that number. So that number is 2. And 2 raised to the power 1 will just give us 2. So that's how you can go about that one. And I also want you to note that if I say square root of 4, it simply means there is an invisible 2 here. So that is what it means. So sometimes you might not even be required to put the 2 there because it means square root. So square root simply means there is a 2 there. Alright, so now let's look at the last law on indices, which is called negative exponent. If we have m raised to the power negative x, the first thing you should do is you have to get rid of the negative. And how can you get rid of the negative? You can get rid of the negative by introducing a 1 on top. Then the whole thing becomes positive. Look at what is going to happen here. So I'm going to say 1 over everything. Then the sign is the only thing that will change. So look at an example, e.g. 2 to the power negative 1. How do I get rid of the negative? So I said introduce a 1 on top, then write the whole thing but don't include the negative. So it becomes 2 to the power positive 1. And what is 2 to the power positive 1? It is just 2. So that one becomes 1 over 2. That's how you can simplify that. It becomes 1 over 2. I hope you've gotten the concept on the laws of indices. Now we're going to use these same laws to help us answer questions on indices. Let us start with the first part, which is simplifying positive, negative, and zero indices. Start the first one. Simplify the following. Again, the question might also say evaluate. It's one and the same. So simplify 5 to the power 0 plus 5 to the power positive 1. So what do we do? Now remember, any number or letter raised to the power 0 is simply 1 plus, then 5 to the power 1 is simply 5. Then 1 plus 5 we get 6. So here we simply get a 6. We got the next one. Negative 3 squared. Negative 3 squared. Now I want you to understand this part because mostly we have people that would confuse negative 3 squared to this. Negative 3 squared is not the same as negative 3 squared. Now those two are not the same. The answer that I'm going to get on the first one and the answer that I'm going to get on the second one is different. Now look at, on the first one it is negative 3 multiplied by negative 3. Then on the second one it is negative 3 multiplied by 3. So this one becomes positive 9. Then that other one becomes negative 9. So that's the thing. So here it is only the 3 which is squared, but the negative will remain. But here both the negative and the 3 are squared. So look at what will happen. Negative 3 squared is simply negative 9, like we have done there. Then we'll say plus 3 squared is 9. What we get when we say negative 9 plus 9, we simply get a 0. Simply get a 0. Look at part C. 4 to the power negative 1. 4 to the power negative 1. First thing, get rid of the negative. Introduce a 1 on top, so that it becomes 4 to the power positive 1. Then we'll say plus x to the power 0. Any number raised to the power 0 is 1. So now I'm going to say this becomes 1 over 4 to the power positive 1 is simply 4. Then we'll add it to 1. Then we'll say over 1. Find the common denominator, which is 4. Then 4 into 4 is 1. 1 times 1 is 1. Plus 1 into 4 is 4. 4 times 1 is 4. Then when we say 1 plus 4, 1 plus 4, we simply get 5 over 4. So we can leave it as an improper fraction like that, or we can write it as a mixed fraction. 4 into 5, it goes there one time. It leaves a remainder of 1, then over 4. You can leave it as an improper fraction or as a mixed fraction. It's okay. Let's proceed to the next segment, and we'll look at how you can simplify fractional indices. Indices with fractional exponents. Let's start. Suppose you've been told to evaluate the following. So this 27 to the power 2 over 3. Now I told you to say, once you see that there is a fractional exponent and it is positive, the first thing you do is you introduce the square root and let the base go inside the root. Then the fraction has got the numerator and the denominator. The denominator goes there. Then the numerator becomes the power of the whole thing. So what do we do now? We are looking for a number that we can multiply 3 times so that we get 27. So a number that you can multiply 3 times so that we get 27. What number is that? So that number becomes 3. Check out. If you say 3 multiplied by 3 is 9, 9 by 3 is 27. So that number is 3, and the 3 is squared. So if we say 3 squared, we get 9, because 3 squared is just 3 times 3. Just a note here, I also noticed something from experience. 3 squared is not the same as 3 times 2. So never mistake that. So 3 squared is not the same as 3 times 2. But 3 squared simply means 3 multiplied by 3. You are multiplying 3 by itself twice. That's what it means. So let's look at this other one. 9 to the power 1 over 2. So the first thing we do, introduce the root, put the base inside, then the denominator goes there, the numerator becomes the power of the whole thing, then there is a plus 1. Then the square root of 9, because this is square. Here we are just simply looking for the cube root because there was a 3 here. We said cube root of 27. So here the square root of 9 is a 3 raised to the power 1, then plus 1. 3 raised to the power 1 is just a 3. Then when we say 3 plus 1, we get a 4. So that's how you can simplify indices involving fractional powers. Okay. We proceed. We look at the last segment, which is solving equations involving indices. How can you solve equations that involve indices? Let us look at 3 examples. So for x, so the first example, we have 25 raised to the x equal to 5. What are we going to do here? The first thing we're going to do is we're going to make sure that the bases are the same. How are we going to do that? So this is what we're going to do. Firstly, you look at the 2 bases. So we have 25 and 5. So those are the 2 bases that we have. So I'm going to do this. We have 25 here and I've got 5. The factors of 25, we have 1, we have 5, then we have 25 itself. Then the factors of 5, we have 1 and 5. then you are looking for the common base except 1. So apart from 1, the common factor here is 5. So that's a common factor apart from 1. So now what are we going to do? We're going to ensure that the base for each index is 5. We're going to ensure that the base for each index is 5. So this is what we're going to do. Let me remove. Okay, so want to see that here we want to make the 25, since here it's already 5. So what we're going to do is this. Let me remove this part. So how can I make 25 to have a base of 5? I can make 25 to have a base of 5 by just saying 5 squared. So if I say 5 squared, it means 5 times 5, and 5 times 5 is 25. So I'm going to do 5 squared, but there is an x, right? So I'll say 5 to the power 2x, because of this x which is there, is equal to this. I'll leave it the way it is so that it becomes 5 to the power 1. So now what happens now if the bases are the same? So if the bases are the same, you cancel them, then you equate the powers. So you say 2x is equal to 1, then we divide by 2, that goes, then x is equal to 1 over 2. So 1 over 2 is the value of x for that one. Alright, now that the value of x has been found, we move on to the second question. We have this 2x squared is equal to 8. What are we going to do? So 2x squared is equal to 8. First things first, here the squared is only for x and not for 2. So the first thing we're going to do is we're going to divide on both sides by 2, even there by 2, so that can go and that can go, so that it becomes x squared is equal to 2 into 8, that is 4. What are we going to do here? So I'm going to say x squared, we can write 4 as 2 squared. Now here we notice that the powers are the same. So if the powers are the same, you cancel them, then you equate the bases. So x will be equal to 2. So the value of x is 2. As simple as that. We look at the last question, which is 8 to the power x minus 1 is equal to 16. What are we going to do? So first things first, we look at the bases. So look at the two bases. So let us compare the two bases. We have 8 and we have 16. What are the factors of 8? We have 1, 2, 4, and 8 itself. The factors of 16, we have 1, 2, 4, 8, and 16 itself. Now we're looking for the common factors apart from 1. So the common factors apart from 1, we have 2 and 4 and 8. So from these that I've circled, consider the smallest. The smallest is 2. So that is the smallest. So what we're going to do is that we're going to reduce these bases to be 2. How are we going to do that? Remember, 8 can be written as 2 to the power 3, because 2 to the power 3 means 2 by 2 by 2 3 times, and 2 by 2 by 2 3 times gives us 8. So 8 is the same as 2 to the power 3, but that 3 is multiplying x minus 1. Don't forget that we already have a power. If you have a power, then you are also raising another power. It means the two powers should multiply. Don't forget that. 16, how can we write 16? We can write 16 to be 2 to the power 4. How? Because if we say 2 times 2 is 4, another 2 times 2 is 4, then 4 by 4 we get 16. So therefore 2 raised to the power 4, we get 16. Now since the bases are the same, you cancel them, then the powers you equate them. So this is 3x minus 1 is equal to 4. So 3 times x, that is 3x, 3 times negative 1, that is negative 3, is equal to 4. then -3 will cross the equal sign, so this will become 4. -3, we add a 3, it becomes positive, so 3x is equal to 4 plus 3, we get 7. Then I'll divide by 3, even this side I'll divide by 3. That goes, that goes. Therefore the value of x will be equal to 7/3. I'll leave it as an improper fraction, and it's going to be accepted just like that. So that's how best you can go about these problems involving indices. Now here is an exercise for you that you should try out. So try out that task and see how best you can go about it.